Hi, my name is Firdaus, and I'll be representing Group 15 to present on our assignment 2. Okay, so right now, as you can see in my pane, you can see this is the default cities that we have chosen, the 5 cities, which are Chicago, Karachi, Moscow, Bordeaux, and Auckland. Okay, so there's also the default ages, the 5 default ages, which are 0 to 1, 1 to 2, 2 to 3, 3 to 2, 3 to 4, and also 0 to 4. Okay, so let's just go ahead and compile this C++ program, and this is the main screen. Okay, you can see there are a few functionalities that this program offers. The first one is to compute the shortest path between two vertices. Okay, so let's say let's look at our graph right now. Okay, let's say that if you want to compute the distance between 0 to 2, which is Chicago to Moscow, so you can see here also there's a possible path between 0 to 2, which is 0 to 1, 1 to 2. So let's just click 1 first to compute the shortest path. Click 1, and then you have to specify the starting index, which is 0, and the end location is 2, and you can see that the minimum distance is 16,000, and even if you verify here, you'll get 12,000 plus 4,000, you get around 16,000 to 17,000, which is the correct value, which is 16,000. Okay, so this is correct. Okay, let's say if we wish to use this, check this functionality is being done by me. So let's say we want to check between, we want to find the minimum path again, 0 to 3. 0 to 3, there's no possible path that the algorithm can traverse through, because there's no there's no possible path to from 0 to 3. So let's just go ahead and try 0 to 3, and you can see that there's an output of no possible path because there's no way for 0 to reach to 3. So the second function is to add random edges to the graph. So if you just click 2, you will simply add a random edge to the graph. This is being done by since this graph is represented using adjacency matrix. Okay, so let's just see the print current graph. We'll look at the third functionality, which is to print the current graph. Okay, right now this is the adjacency matrix representation for the current graph. So there's a value here 12146. This is 0 1. I is the 0, j is 1, so it means that there's a connecting edge between 0 to 1, and the weight is 12146. And even if you can look here, you can see that it is true. Chicago is connected to Karachi with a weight value of 12146, and for this number 21, you can see that it occurs a few times, actually not a few, a lot of times. This is actually the maximum value that C++ can represent for an integer variable. So we have decided to represent cells that are actually edges that are not present. Okay, let's say 0 to 2 is not present here. So if you look at 0 to, it is represented as this maximum value. It means that there's no possible edge, or there's no connecting edge between the two vertices. So that's the convention that we have chosen to use for this particular program. And okay, we'll go ahead and see this is 0 to 4. You can see that 0 is connected to 4 with a weight value of 13191, and other values 4177. This is 1 3. 1 is 1 0 1 1 1 2. 1 2 is 4177. Okay, it's correct. Other values is here. This is 0 1 2 3 3 0 3 1 3 2. This is 3 2. 3 is connected to 2 with a weight value of 2924. Okay, and so on. The last value is this one, 3 to 4. 3 to 4 is 19045. Okay, so it's correct. So that's for the print current graph functionality. So the next one is to reset graph to default. That one we'll just use it for the end. Okay, so let's just go ahead and try to add random edges to the graph. So if you click 2, it would randomly generate a value for the I and j, and then you will just simply add that value into the respective cell that it represents. So the randomly generated number is 4 and 1, and the distance is between that means 4 to 1. 4 to 1 is the distance is 13153. So let me just go ahead and draw here first. 4 to 1 is 13153. Okay, and the way that this function knows the distance value is that I've already specified in my program a case function inside the functionality of adding random edges. So I have to manually set for each vertices to another vertices. Each vertex to other vertex for every cases. So I have to manually check, and so if the randomly generated number is 4 to 1, you can see for the case if it's 4. If the case is 4, and then if the random j is equals to 1, you will add this function. If it's 4, if the randomly generated number is 4 0, you will add here this value 1 3 1 and 1. If it's 4 2, you add this, and so on and so forth. So for every value I've already put on the right case function. Okay, so that's for the randomly adding new age functionality. So next we'll move on to the strongly connected function, which is 6. This is done by Fatini. So if you click 6, it will just simply tell us whether the graph is strongly or not strongly connected. So for this case, for this current graph, it is not strongly connected, because you can see that there are vertices that cannot reach other vertices. For instance, 0 cannot reach 3, 0 cannot also reach 0 can reach 2, 1 cannot reach 4, and there are multiple vertices that cannot reach multiple vertices. Okay, so that's why it's currently showing us that it's not strongly connected. So the next function is to check whether it is as a cyclic property or not. So if we look at our current graph, let's just see whether there's a cycle currently. So currently there's no cycle. So theoretically speaking, if we click 7, it should give us that. Okay, it's correct. So the graph has no cycle. So it is true that this current graph has no cycle. So let's just go ahead and try to test, try to add more random edges. Since for the current cell, okay, let's just look at the current graph. Current graph, you just click 3. Okay, right now there are 25 possible cells value. So for the default value, there's 5 value. I have already set this connecting 0 to 1. The default value, there's 5. And for the function of adding random edges, I also have specified the condition of not adding for the same I and j value. That means 0 0 1 1, 0 0 0 0 1 1 1, 2 2, 3 3, and 4 4 would not be able to add values for these cells. So since there are 25 possible values, you minus the 5 default value, you get 20, and you minus the 5 values that would never be able to put values in, which is the 0 for the I and j, same value 5 also. So there's 15 times that you can add random edges to the graph before there's no possible edges to be added anymore. So right now you already just add 1, just now add 4 to 1 randomly. So if you click 2, so this is the second one, 0 to 3, you add 0 to 3, you can just draw an arrow 0 to 3, and the value is 6 6 8 7, right? 6 6 8 7. So right now you can see that there's a connecting path between 0 to 3. Actually there's only one path, 0 to 3, 0 to 4. Okay, this is an interesting case, because you can see that 0, let's say you want to go 0 to 4, there are two possible paths. You can directly go 0 to 4, and you can also use the path of 0 to 3, 3 to 4. So if it's 0 to 4, you'll get 1 3 1 and 1, and if you go to 0 3 0 4, you'll get 13,000. It is 6,000 plus 19, you get around 25,000. So theoretically speaking, it should give us this minimum distance, 0 to 4 directly, not 0 to 3, 3 to 4. So let's just go ahead and test our program. We click 1 and 0 for the starting index and 4 for the end location. So you can see that the minimum distance output by the system is by the program is 1 3 1 and 1. That means it has correctly identified that the minimum is 1 3 1 and 1. Okay, so it means that it has correctly chosen the correct minimum path, because there are two possible paths, and it has correctly chosen the correct minimum path. Okay, right now let's just test for other properties. For strongly connected, it's not strongly, even cyclic is not cyclic. So let's just add more random edges. Click 2, and the new random edge is 2 to 3. Let's just draw a line between 2 to 3. Okay, right now it's 3 to 2, but 2 to 3 we have just newly added a line. Okay, so this is the end of part 1. I'll see you in part 2.